Okay, so now you know about embeddings, but do you really know what are all the real use cases of embedding in natural language processing? You will be surprised to know that embedding is the backbone of almost every NLP use cases. So let us see some of the use cases. So embeddings are used in text classification, information retrieval, machine translation, text generation, recommendation system, anomaly detection, question answering system, and many more, because it is the backbone of almost every natural language processing or large language model use cases. Question answering system is one of the most important use case in natural language processing, large language models, and generative AI. It is about providing a natural language interface through which people can search some information. These informations are spread across multiple documents. So instead of people going and searching through the various documents, they can make use of the single natural language interface, type a query, and the system takes care of searching across multiple documents and bringing the best result to the end user. So let us see how a question answering system is implemented. Implementing an end-to-end question answering system using document embedding involves two primary components. Number one, the context retriever, and number two, answer generator. This process unfolds through the following steps. Step number one, which is document embedding. The documents are initially segmented into small chunks, and then utilizing embedding model, each chunk is transformed into embedding vector. Step two is about user query embedding. So when a user asks a question, the query is converted into an embedding vector using the same embedding model. Step three is about semantic search. Semantic search is executed by comparing the query vector with chunk embedding vector in the database. Cosine similarity is used to assess the similarity between the query vector and each chunk vector, and the top matching chunks are returned. Then the final step is answer generation. The user query and the best match chunks are forwarded to a generative model. The generative model is instructed through prompt engineering to produce the final result. Ultimately, the question answering system seamlessly integrates user queries and the most relevant contexts, employing a generative model to craft precise and contextually appropriate answers. In this hands-on exercise, we are going to implement question answering system for PDF document. We will be implementing this in Python. At high level, we know that we have to do the followings. Number one, loading and chunking our PDF files. So for loading and chunking our PDF files, we are going to use a LangChain open source library. Then we know that once our document is loaded and segmented into small chunks, we need to do embedding. For embedding, we are going to use sentence transformer models and library for embedding purpose. Once our chunks are embedded, then we need to store this embedding into embedding database. So we are going to use ChromaDB to store our embedding vector. And then to generate the final answer, we are going to use OpenAI's generative model, GPT 3.5 Turbo, which can understand and generate a natural language text. Okay, so we are all set. So let us do some coding now. First, we will be installing needed libraries. So these libraries needs to be installed. This is one-time job, so just install them once. Because I have already installed this, so that is why it is saying requirement already satisfied. But in your case, it will try to install from scratch. Once this installation is done, then we will set up the storage where we will keep our PDF file, and also on this storage, we will keep our embedding vector. So I'm going to use my G drive. So I'm mounting my G drive. If you are using your local drive, then no need to mount. You can directly configure the path for your PDF document and for embedding vector. Then we will import the needed libraries. So these are some of the needed libraries which we are going to import. We also need to configure our OpenAI API key. As I said, to generate the final answer, we are using GPT 3.5 Turbo model from OpenAI. And for that, we need to configure the API key. So you need to generate your API key on OpenAI, and then you can use that API key in this Jupyter notebook. Now we need to configure these two paths. One is the path of our PDF document. So this is the path where I have kept my PDF document. I'm going to use the transformer white paper as an input data source. So we will be building our question answering system on top of this PDF document. And then another path is the persistent directory for embedding. So this is the location where embedding vector will be stored. So ChromaDB will store the embedding vector on this path. Now let us load our PDF document. So to load our PDF document, I'm using PyPDF loader, which is part of LangChain library. PyPDF loader loads this PDF using PyPDF into array of documents where each document contains the page content and metadata with page number. So now once these documents are loaded, so we can see how many pages are there. So if we just do length of pages, we get 15, and we can also see how many pages are there in the original paper. So this is the original paper. Attention is all you need is a transformer white paper, and we can see that this document has 15 pages. So we are all set as far as loading is concerned. We can also see the page content. Now our PDF is loaded, and we can also see there are 15 pages in this document. Now we will do chunking of PDF document. So for chunking, as I said, we are going to use again LangChain library. And from LangChain, we are going to use recursive character text splitter. You can access the LangChain documentation, and then you can see the different chunking methods which they have. But we are going to use for this example, recursive character text splitter. This text splitter is the recommended one for generic texts. Here there are two parameters which we can configure. I would say a tuning parameter for chunking. One is chunk size and another one is chunk overlap. So I'm setting chunk size as 1000 and chunk overlap as 100. These are number of characters. So once this chunking is done, we can check the chunk length. So we have total about 49 chunks. So remember, original documents had 15 pages. Now those 15 pages are segmented into 49 chunks. We can also see the content of each chunk. So this is the content of chunk number 1. The chunk actually starts with 0 because index start with 0. So you can also see the content of chunk 0. After chunking, we need to do embedding. For this, we are going to use open source model from sentence transformer. There are these two models. You can try with both of them. The difference is that one is having 384 dimension and another one is having 768 dimension. Okay, so let's load one of these models and create the embedding function. Once model is loaded and we have our embedding function, let's use it to do embedding for all the chunks. For embedding, we are going to use a function from LangChain, which is from underscore documents. This from underscore documents method creates a new ChromaDB instance and populates its vector store with the provided documents. It does this by extracting and iterating through the text from those chunks and the optional metadata available on those chunks, and then embed them and add them to the vector store. It takes 3 parameters. One is documents where we need to configure our chunks. Then the second one is embedding where we need to configure our embedding function. Then the third one is persist directory where we need to provide the path where this ChromaDB will store the embedding vector. Now, once this is set, let us run this and do the embedding. it might take some time. Okay, so our embedding is done and it is stored at the provided path. Okay, so this is our path which we configured. So let us see if we have our embedding available here. So this is my G drive. In the G drive, sample data, under sample data, this embedding vector is the location we gave, and under this, yes. So we can see that embedding is created and stored here. Fine. Now let us do some quick checks just to ensure that we are getting the right chunk for any query. So say our user query is what is transformer, and I expect that this transformer paper will have some section to answer this question. Now to search the relevant chunk from the embedding vector for this user query, we are going to use this function called similarity search. This is again from LangChain. How similarity search works is explained here. Just to give you at the very high level how it works is that you see how we are calling this function. We are calling this as db.similaritySearch. Now this db is nothing but the chroma db instance which we created before, and it already has the embedding model associated with it. So when this similarity search is called using this db dot, that embedding model is also already associated with this function. So when user query is passed to this similarity search, what it does is basically it converts this user query into query vector using the same embedding model. The generated query embedding is then compared to the embeddings of the text chunk stored in the Chroma database. So it has already the access to the Chroma DB or the embedding vector which was created, which contains the embedding vector of the entire chunk. So after it converts this query into query vector, it uses the cosine similarity and does the semantic search between the user query vector and the chunk embedding vector. The chunks with the highest similarity scores are retrieved and returned as the result of the search. Another important thing to note here is that we're also passing one more parameter, which is k. This argument k specifies the number of top or similar chunk which should be retrieved. It is very important to optimize this chunk number, because imagine you set this as say 5, then for every user query you are going to get 5 chunks from the similarity search. And then to generate the final answer, which I will be explaining further, we are going to pass those many chunks along with the user query to the generative model. And that generative model we are using from OpenAI, which is GPT 3.5 Turbo. How they charge is basically a number of tokens. So the more tokens or the more chunk you pass, you are passing more tokens. So they're going to charge you more. And that is why it is always good to optimize this chunk number. So in our case, we are just setting k equals 1. We are just going to use only one chunk. So we are setting k equals 1. Now let us print the result. So for the user query, what is transformer, we got this result, and this is the page content. So the page content is having this text. And we can see that it has content which can be used to answer the user query. So if this piece of text is provided to a human, he can form an answer using this text for the user query. Okay, so far we are successful. We are able to load our PDF document. We are able to segment our PDF document into different chunks, and then we are also able to create the embedding vector. We are also able to load our embedding vector into Chroma DB, and we are also able to search through that Chroma DB, and we are also able to retrieve the relevant chunk for the user query. So far so good. Now to generate the final answer through generative model, we need to pass this user query and this search result to the generative model. Okay, so to do that, I'm going to write two helper functions. One is search chroma db. This search chroma db is a helper function where I'm going to use the same db.similarity search. I'm going to call inside this function. So I'm going to call the same similarity search function. But in addition, what I'm also doing is I have just added some checks. Nothing else. Rest all are same. Another helper function which I have written is generate answer. This generate answer will take two arguments. One is the user query and this context. This context is nothing but the semantic search result, the chunk which was found as part of semantic search. And using these two parameters, it will call this client.chat.completion.create API from OpenAI. This API has its own list of parameters. So these are the list of parameters of this API. So it has the model. So we are going to use GPT 3.5 Turbo model. Then it has these messages. So inside these messages, we are going to write our system prompt and we are going to write our user prompt. Then it also has a parameter called max tokens. So this max tokens is a limit on the maximum number of tokens when model generates the answer or the response. This is the limit set by the user. So the model will not generate any answer which is going beyond 500 tokens just to control the usage. You can read through these parameters. Another important parameter which I would like to mention here is this temperature. This temperature is typically, it ranges between 0 and 1. 0 means the model becomes deterministic. It always going to return the same output for same prompt and context. This makes the response predictable but potentially less creative. And when it is set to 1, that means the model is at its most creative and diverse level and is going to explore wider range of possibilities to generate the response. Values between 0 and 1 offer a trade-off between these extremes. So in our case, we are going to set 0 because we want our answer or the model's response to be more deterministic. I want to also highlight this system prompt and user prompt, which is part of this messages. System prompt, we are saying answer the question based on the context below. So the context which we are passing, this context which we are passing, so we are instructing this generative model to answer the question out of this context. So if answer is not available in this context, just say, I don't know, and don't make up your own answer. Okay, so using these two helper function, search chroma db and generate answer, let us implement our application. So we will first load our embedding vector. So to load our embedding vector, again, we are calling this chroma function, and then we are passing the path of our embedding vector and the function. So once this embedding vector is loaded, I have just written this small piece of code which has a while loop. And what it does is basically it provides you the prompt where user can ask query, and user can also type this quit or q or this q to exit the prompt or ask question. If user asks question, what it does is basically it is going to first call the search chroma db, the first helper function. It is going to pass the loaded embedding vector and then user query with k value 1 because I want the topmost result. I don't want many chunks because I don't want to consume my usage on OpenAI side. So this k is 1 I'm setting, and once my chunk is available, that is the result of my user query is available, then I'm going to call my second helper function, generate underscore answer, and there I'm going to pass the user query and this context. And then this generate underscore answer is going to return me the actual answer. So before we run this while loop, I think we have not executed these two helper functions. So let me first execute these two helper functions. Okay, now let us run this. So it is saying my hello world question answering system, and it is asking me to enter a question. So let us type the question, say what is transformer. Okay, so it has returned the chunk from semantic search. So this is the output of the first helper function, which is search chroma db. So it has returned this chunk, and now in the generate underscore answer, this chunk is passed along with the user query, and then the generative model has generated this answer. So it is saying the transformer is a model architecture that uses stacked self-attention and point-wise fully connected layers for both the encoder and decoder. So based on the user query and the semantic search result, the generative model is able to answer the user query. Let us ask another question, say who implemented transformer model? Very good. So it is saying, see, Ashish and Elia implemented the first transformer model. So because they are the author of this paper and they are the one, a team of them have implemented this transformer model. So far our question answering system is working fine. I hope this will help you to learn the concepts of semantic search, the concepts of using some open source libraries like LangChain, the concepts of using some open source embedding model, and then how to use the OpenAI generative model, how to use OpenAI APIs and call their generative model to answer the user query based on the context provided to the model.